Good day, hello and welcome. We will now begin with the first lecture for our finals period, which is about the TCP IP layers. The last lecture we had a week ago was, if I'm not mistaken, about IP addressing and subnetting. So for today, we'll delve deeper into the protocols and services under the TCP IP layers. If you can remember, we actually differentiated the OSI layers with the TCP IP layers. The OSI layers having 7 layers and TCP IP having only 4 layers. As such, we will now be going into each of the layers and we will be specifying each of the most common services and protocols under each layer. So, we will begin with the discussion of the application layer. Then we'll go to the other 3 layers successively: the transport layer, internet layer, the network access layer, and for the lecture next week, we will be focusing on networking tools. So for now, for this specific lecture, we will be focusing on the layers. Let's begin with the application layer. As defined last time, the application layer is actually the interface of our application with our network. So by using a variety of protocols, it allows applications to ask for services or service requests, especially when they are going to access or be needing the network. Application layer functions includes but not limited to handling high-level protocols, issuing of representation, data encoding, and dialog control. As mentioned from our last discussion of the differences between the TCP/IP layer and the OSI layer. So some of the common services included with the application layer are the following. For email, we have the SMTP and POP3. SMTP would be Simple Mail Transfer Protocol. So if we have an email client, for example, we have Microsoft Outlook or Thunderbird installed in our desktop. SMTP is used to send our email from our computer, our device, towards the mail server. Now, if we're going to retrieve an email from the web server, or from the mail server rather, to our computer, then we use POP3 or Post Office Protocol version 3. There is another email protocol that is commonly used aside from POP3, which is IMAP. The main difference between POP3 and IMAP is that in POP3, when an email is retrieved from the mail server, the contents of the mail server is deleted. So that specific copy of the email is gone from the mail server. But with IMAP, you can actually have many devices getting emails from the mail server, as all emails gathered from the mail server are not deleted in IMAP. Next, we have several protocols and services used when transferring data from one host to another host or one computer to another. So we have TFTP or Trivial File Transfer Protocol and FTP. One of the main difference between TFTP and FTP is that TFTP uses UDP or User Datagram Protocol and FTP uses TCP. We'll describe the difference between UDP and TCP later, as it is included in one of the layers. But one of the main reasons we use TFTP is it's less complex than FTP, but it is also less secure than FTP. That is why TFTP is usually used for exchanging information within a local area network. But for exchanging information or data using the public network or the public domain, we use FTP. But the main problem with FTP is that it's a bit more complex to establish, as you would be needing a separate, or you have to establish a separate FTP server. Well, you do need a server for TFTP, but setting up a TFTP server is much less complex or simpler compared to FTP. Another service included with the application layer is NFS, or Network File System. Using NFS or Network File System, we can actually connect a drive from another computer and have access from another computer, such that that local drive or that drive from another computer looks like a local drive from our computer. Remember that when we look at our directories or folders in our computers, we actually see a list of drives depending on the partitions and the number of physical drives that we have. And more often than not, those are the partitions and hard drives or secondary memory installed or physically installed in our desktops. But we could actually have another drive that is not physically within our desktop, but it is in another computer, as long as they are connected via network and connected or accessed via NFS. So it would appear that it's a local drive, but it's technically in a different computer. Next, we have DNS, Domain Name System. DNS is the one that translates domain addresses into IP addresses. Our routers and the network itself could identify whole destinations and sources and even intermediary nodes through their IP addresses. It could understand URLs or domain names. As such, there is a need for a server that would translate the addresses or the links that we click in a web page or a browser into an IP address. And that is what the DNS is for. Next, we have Telnet and RLogin. Telnet and RLogin are almost the same. Their main function is it allows us to connect to another computer and give commands from our computer. So sort of like remote desktop activation. I can control, issue commands, manipulate files from your computer from my computer, or to your computer from my computer. I'll just need, of course, a setup, input my username and password, and then I'm good to go. The main difference with Telnet and RLogin is that with RLogin, I can actually have, I can set it up to automatically log in to the target computer every time. That would be a security issue, as such that if that computer is unattended physically, then somebody else might be able to log into that computer as well. With Telnet, you have to put in your login, your username and password every time. Both Telnet and RLogin are seldom used today, if not used, as there is a more secure form of getting commands from a computer called SSH, or Secure Shell. Then we have HTTP, or Hypertext Transfer Protocol. This is the service or protocol used that allows the browser to communicate with the web server and vice versa. So, for instance, we put in an address on our browser. Once we click enter or click go, it would actually send a message to the web server asking permission or requesting for access to that specific web page. And then the web server will answer back using HTTP. Don't confuse this with HTML, because HTML is the language that formats or allows us to see the formatting within our browser. The images, the hyperlinks, and the text. Unfortunately, HTTP is unsecure. So that's why we have HTTPS, which is much more secure than HTTP. Why is HTTP unsecure? Because when it sends requests or answers requests through the network, it's actually in plain text. So if you are knowledgeable with HTML syntax, you'll be able to easily identify the data that is transferred. That would include usernames and passwords, credit card numbers, especially if someone is snooping around within the network. With HTTPS, using SSL, now they use TSL, but the main idea is that any message transferred between the web server and the host computer using HTTPS uses or encrypts data first in such a way that when someone intercepts the message, they won't be able to understand it unless they have a copy of the public key. So that makes HTTPS much more secure, and the one used when dealing with financial institutions, with mobile banking, and other websites that have or that where you put in your username and password. Part of the application layer is also the SNMP, or Simple Network Management Protocol. So this is the main protocol used when monitoring and controlling the exchange of management information, and those management information is the one used by system administrators and network administrators to make timely decisions or to monitor network activity and such be able to act accordingly. SNMP is divided into three components, which is the managed devices. That would include the computers, the routers, the switches, etc. The agent. The agent is the one that translates all incoming information from the network or management information from the network and translates it to a form that is understandable by the NMS or the network management software. Because not all data coming from the managed devices is compatible with the NMS. Someone has to translate it into a form understandable by the NMS. And that is where the agent comes in. Then the NMS, or the network management software or network management system in some books or some literature, is the interface with the system administrator or the network administrator. So this is the one that we usually see and gives us like a summary or even a detailed look on what's going on the present with the network or history, or what goes on in the history of the network. Next, we have the transport layer. The transport layer is the one that ensures the reliable and efficient delivery of data. Now, one way of doing this, or the most common way of doing this, is what we call the triple or the three-way handshake. Okay? So we'll talk about the three-way handshake in detail. So in the three-way handshake, we actually get acknowledgement first before sending data. So let's say we have two computers and then the host or the source computer is sending data to the destination computer. Once the sender transmits a single packet, before it sends the second packet, it would wait for an acknowledgement from the receiver. This flow control process is called windowing. Now, as the receiver, once I receive a packet, either I have to answer not ready or ready. The times that I answer, or the host or the receiving computer answers not ready, is when the receiving computer or the receiver has a full buffer. That means any data coming in would not be accepted by the buffer but would be lost instead. So it would tell the source not to send data yet. But if the receiver has still space in its buffer, it will send a ready signal. If the receiver has cleared space for the incoming data, it would also send a ready signal. We call this mechanism of sending ready signals and not ready signals, or waiting for such, is called acknowledgement. The sender would not be sending any signals without any acknowledgement. So that is what we call the three-way handshake. Now, transport layer protocols has two common data protocols. So we have the TCP, which uses the three-way handshake, and the UDP. We mentioned this a while ago as one of the main differences with trivial FTP and FTP. With TCP, connection is established first before sending data. That would mean that TCP is actually much more reliable in sending data. It can actually do error detection and correction, congestion and flow control, and it can suppress duplicate data. Unfortunately, in order for TCP to do this, it needs to add more overhead to each packet, making the data size or the packet size much larger. On the other hand, UDP is a connectionless protocol. Connectionless in the sense that it doesn't establish connection like TCP does. So it doesn't wait for an acknowledgement before sending data. It does not ensure that there is a reliable connection between the two, but it just sends data from the source, and if it is received or not is not a problem anymore of the source. It doesn't have all the error detection, data suppression, flow and congestion control mechanisms available with TCP, but UDP itself has some sort of error control, but not error correction. When it detects an error, it can detect errors, but it would just release or delete the incoming packet. UDP is used with multicast or broadcast systems, and for systems that can tolerate low rate or a certain rate of error. So that's why UDP is usually used for online games, as UDP would give a lower ping compared to TCP. Next, we have the internet layer. So the internet layer is the one responsible for the delivery of service requests from the bottom layer to its layer, or from the upper layer to the internet layer, and make sure that it arrives at its destination. Some of the protocols under internet layer is IP, or Internet Protocol. So IP is the one that is managing the addressing of the nodes, such that any data being sent to the internet or the public domain or the public network would be able to actually arrive at a specific destination, as each nodes and of course the source and destination themselves have their own IP address. It also performs packet definition and data transfer between the internet layer and the network access layers, and the one that is responsible for routing. So without IP addressing, routing would be impossible. We will be discussing routing as the final part of the discussion for this course. Next, we have ICMP, or Internet Control Management Protocol. As the name suggests, this is the one that is used for maintenance of the network and used for troubleshooting techniques when looking into a network as well. So it handles errors and controls the process of sending data between computers. The last part of the discussion next week with regards to network commands, most of them are actually under ICMP. Next, we have IGMP, or Internet Group Management Protocol, and this is the one used for multicasting. When we send data from source to destination, it's usually in unicast. But when we send data to multiple destinations, we call that as multicast. So what's the difference between the two? Let's say I'm sending data to 4 computers, but I'm sending the same data individually, or I'm making 4 copies of each. I'm not actually doing multicasting. I'm actually doing 4 separate versions of unicast. Now, the main problem with that is because I'm making 4 exact copies of the same data, it would actually occupy 4 times the bandwidth. But with multicasting using IGMP, I can send a single copy of the data, and because the router or the network knows that I am using a multicast, doing the copy or getting a copy of that specific data that I'm sending is done near the destination. That means bandwidth is actually conserved, and it makes it much more efficient. Next, we have ARP and RARP. ARP stands for Address Resolution Protocol, and RARP stands for Reverse Address Resolution Package, or Resolution Protocol. ARP, remember when we connect to the internet or to a network, we must have both a physical address and a logical address, or we must make a physical connection and a logical connection. As such, we also have 2 addresses, our physical address and IP address. The physical address will be our MAC address, and our logical address would be our IP address. The MAC address found in each machine is actually unique and unchanging. IP address could change, could be dynamically allocated, or could be statically allocated as well. But more or less, a physical address is paired with a matching IP address. Now, when we send data to the network, we actually use the IP address such that it would be sent to the intended destination, and that if they would be answering back, it would go back to us, the original sender. And that would be needing an IP address. But if we're on a network, the switches also have a copy of our physical address that match with the address or IP address given. And that is done through the ARP. So we are able to obtain a physical address given a specific IP address. The reverse is also true. So we also have the Reverse Address Resolution Protocol, in which we get the internet address or the IP address given the physical address. So this time around in RARP, the IP address is missing, but we have the physical address. RARP is used if there is no local drive in which we could actually save the IP address. So we only know our physical address, but we don't know our IP address as we don't have any way of storing it locally. So we use RARP to look into the table and see what our IP address is. But most of the time, we have a local drive or a local way of actually storing our IP address. So ARP is much more used compared to RARP or RARP. The last layer that we have for the TCP IP is the network access layer. So this is concerned with the way that we can physically connect our network. That would include also physical connections and even the mapping of the IP addressing together with the physical hardware. This would also include the encapsulation of the IP packets before being sent through the medium. The network access layer includes the following protocols. For local area networks, we have the Ethernet. So the Ethernet was actually not created, but rather formulated or designed through the efforts of IEEE with the protocol number being 802.3. So if you actually look at the 802 family, you'll see a bunch of networking terminologies there. But for Ethernet or local area network connection to the Ethernet, we use 802.3. Ethernet uses best effort service using CSMACD or carrier sense multiple access with collision detection. Now, if we're going to send data to a serial line between a single source and a single destination, we use PPP or point-to-point protocol. If we're going to send it to fiber through a dual ring topology, we use FDDI or fiber distributed data interface. We talked about dual ring topology when we talked about topologies before and its advantages and disadvantages. So FDDI is dual ring topology that uses fiber as its main medium of connection. For wide area networks, we use asynchronous transfer mode and frame relay. Frame relay is actually slower compared to ATM. So ATM is much more used compared to frame relay. As ATM has better efficiency, better error detection and correction, better overall speeds. The older X.25 is not mentioned here, but that is one of the old protocols used for wide area networks. The network access layer also includes ARP and RARP. So we already know what ARP does. It gives us a physical address given the IP address, and the RARP gives an IP address given the physical address. But in addition, we also have what we call the Proxy ARP or Proxy ARP. So what the Proxy ARP does is an intermediary node or device accepts data for us in such a way that normally when we send data, it is intended for a specific physical address. With Proxy ARP, let's say a router, we are connected to a specific switch or router. The router could act as the recipient of the data, and then the router would pass through us the data that has been received. There are actually many more protocols within the TCP IP suite, but we just covered the most common and most basic, even one of the oldest or older protocols and services, as we don't have that much time to cover all of them. Anyway, next week we will be tackling the last part of the first lecture for the finals, which is about the network commands. So we'll be learning of some of the network commands used in network technologies, and most of them are under ICMP. As always, if you have any questions, don't hesitate to comment or message me for that matter. Anyway, thank you very much and have a good day. Stay safe.